So we were just talking a little bit about in the last video about looking through the test.py and understanding how the program is being tested from the outside through the user interface, and that being the key difference between the unit tests, which are just individually testing those functions, passing in the values, and getting back a value directly inside Python. To me, I find that usually a lot easier to test. Here I have to work at the level of creating these strings, running the program, getting back the return value in the output, and then stripping and handling all this text output from the program and verifying that that text looks like this expected text, which is all a bit clumsier, but is a really vital part to checking your program. It's really important to use both unit tests and integration tests. But if we're really going to verify that what the user sees works, we need to write integration tests. And then here, from the outside, this looks very similar to, it's pretty much exactly the same as the unit test, but I'm passing in these winning configurations, and I'm asserting that that the last line of the output says player has won. Since I'm already checking the board output earlier, I'm not really worried about that. And I'm doing the same thing here with this losing. So verifying that I'm really checking all these things. In the discussion, there's a bit more about just making sure you really understand the and, the ORing, and any, how the relationship between, if you put OR between a bunch of Boolean values or truthy values, so true or false or true, it's going to return true because there is a true value in there, and that's what any does. It's essentially just putting OR in between all of those. And so what I'm showing here is that if both cell and player are some non-false value, they're both truthy, then any is going to return true for that. And all is the same as putting and in between these two things. It's going to return the first truthy value. So cell and player is going to return X, but player and cell is going to return 1. So using all is basically like putting cell and player. It's true that both of those things are true. So if we set one of these things to nothing, to none, then it's true that one of them is true, but it's not true that they both are, that everything in that list is. And so we can actually reduce all of that with a combination of any and all and we can get a single true or false value. And so that's what's going on there. I talked a bit about understanding this regular expression, so hopefully this is not you understand this now. Another way to write this without a regular expression, however, would be to simply say, is it true that the length of the board is 9? So that's essentially handling that this part here, that it's 9 characters. And is it true that all of the characters, so for C in board, for character in board, that character is in the set of dot X and O? So if both of these things are true, then it's true that the board is valid. So you don't have to write a regular expression, but you are essentially doing the work of a regular expression engine. For something as simple as this, yes, it's okay. But as your patterns get more complicated, you really, really need to use regular expressions. So a little bit more about using all there to check each one of the characters. I think that's really useful. And then let's see, moving forward, we talked about formatting the board. I want to point out here that the splat syntax is the same as essentially writing these out, cells 1, cells 0, 1, 2. We need format needs a list of values, and the list slice doesn't actually quite give it what it needs for cells for the format method. We need to use the splat to essentially expand that into the values that the format needs. So it's a shorter way of writing this same bit. And here I see I've got the correct. This is actually the correct code. There's a typo in the earlier version, in the earlier bit of this code. So we talked also about the enumerate function. I hope that you really understand that. Here's enumerating the board. Normally would start counting at 0, but we want to count at 1. So here I'm saying start is equal to 1. You can actually just say 1 or whatever is the value that you want to start at. So pointing out what that looks like, enumerate couples the index and the values from a list and creates a list of tuples that has those two things together. So hopefully you understand how I'm doing that. Just the way that I'm unpacking for I and char from that. So I want I as the index and char as the character, and I'm getting that out of enumerate. Those are being unpacked like this. I'm also doing the same thing later with the I, J, and K. Hopefully you see that. So for I, J, and K and winning, it's going to take 0 and put that into I, 1 is going to go into J, and 2 is going to go into K, and it's going to do that for each one of these sublists. So hopefully you understand the unpacking there that's happening in both of these. Very, very useful to be able to know. This was one way that I came up of writing the finding the winner. I created this combo with each of the positions, which each of the values from the board, and I say, is it the same as? Sorry, my timer just went off. And is that the same as player, player, player? That's one way of determining that the combo is right. Another way is to use all again. And so here I actually came up with, I'm sure you won't be surprised, I came up with like 7 or 8 different ways to write this. And this was just another way that I liked doing it. I used a map, taking each one of the board, and I want to get out the board at that position for this combo. So instead of unpacking I, J, and K and winning, I'm just leaving those as a list, and I'm passing that list as the argument to this map. And I need to expand that using a list here. So this gives me this group that's going to be like XOX or X dot dot or something like that. This is going to be itself a list. And so I'm saying if all, and I'm doing for X in group for whatever value, X here is not, don't think about the player X, but just some unknown value. So for each value in group, is that value equal to the player? And so I'm creating a list of Booleans, and then I'm reducing those with all. So if it's true that all of these things are equal to the same player, then return that player. So it's really the same logic as what the other thing I wrote, just another way of writing it. One other thing to point out here is notice that the all, this looks like a list comprehension, but you see that there's no brackets around this. It's actually, the parentheses here are creating what's called a generator. So if you take a list comprehension and instead of writing it in square, so that if you put it in square brackets, it will create a list at that moment in the code. If instead you put those in parentheses, then it creates a generator that will generate the values as you need them. It's an extremely useful tool to understand. And so if I put all outside of this, then it turns this into a generator. All consumes the values and actually handles it. It actually consumes all the values and then evaluates the all. So this works here, but that's not a typo. That you can actually write that. This is a generator in here, which is essentially a list comprehension, a lazy list comprehension. And then we talked about here about how to find the winner and how to print the outcome of the game. So that was a lot of effort to just handle understanding one turn of tic-tac-toe. And in the next chapter, we're going to expand on this and to make it into an interactive program. But I think that you'll find that that program is going to be significantly easier to write because we spent so much time understanding the fundamentals of how we would write this game. There's lots of other games that you should try writing. Try your hand at writing a card game like Blackjack, which is 21, or the game called War. Also, Hangman is a really popular one to try to write. So lots of fun, simple games that you understand from your childhood that actually present quite a few engineering challenges when you try to write them out. And so let's go to the next chapter, and we'll finish up the book.